For decades, the skies have held mysteries that science couldn't explain. Whispers of UFOs, alien technology, and secret government projects have captured our imaginations. But what if those whispers weren't just rumors? What if the future of flight and physics as we know it was being tested in plain sight? Join us as we uncover the U.S. top-secret UFO fighter jets that could rewrite physics. In the vast emptiness of the Mojave Desert, a remote and unassuming site was quietly established in 1955, one that would later become synonymous with secrecy, speculation, and the pursuit of the impossible. About 80 miles northwest of Las Vegas, the U.S. Air Force, the CIA, and Lockheed Martin selected this desolate stretch of land as the perfect location to test the most advanced and mysterious aircraft ever conceived. Known today as Area 51, it has since evolved into a symbol of government secrecy and the unknown. At the core of Area 51's origins lies the U-2 spy plane, a marvel of engineering that forever changed the landscape of reconnaissance and unwittingly fueled an explosion of UFO sightings across the United States. The U-2 was an aircraft unlike any other, designed to fly at astonishing altitudes of over 70,000 feet, far beyond the reach of conventional planes and radar systems. Its sleek, alien-like profile against the thin stratospheric air only added to its mystique. Pilots wearing pressurized suits, resembling astronauts, maneuvered this extraordinary machine in the harsh environment of near space, gathering intelligence that was previously unattainable. Its capabilities extended far beyond mere surveillance. The U-2 could capture detailed images with high-resolution cameras, detect faint signals with advanced sensors, and provide data from the electromagnetic spectrum invisible to the human eye. The innovation didn't stop there. This aircraft was equipped with a range of tools, from synthetic aperture radar to optical bar cameras that captured imagery with astounding clarity. Some data could even be transmitted in near real-time via advanced air-to-satellite communication, while other intelligence, like wet film, had to be analyzed post-mission. These advancements not only made the U-2 a critical asset during the Cold War, but also placed it decades ahead of its time, blurring the line between human ingenuity and science fiction. Despite its significance, the U-2's presence had to remain hidden from the public eye. Area 51 became a tightly guarded enclave where innovation thrived under a veil of secrecy. All activity and research within its boundaries were classified as top-secret, sensitive, compartmented information. Even as strange aircraft sightings multiplied, government officials adamantly denied their existence, going to great lengths to maintain the illusion of normalcy. The denial only fueled public curiosity and conspiracy theories. Many Americans believed that they had glimpsed extraterrestrial visitors, unaware that the aliens were cutting-edge American aircraft, built to outfly and outwit adversaries. Flying the U-2 was no task for the faint-hearted. Pilots faced unparalleled challenges, particularly during landings. The aircraft's bicycle-style landing gear and poor forward visibility, hindered by its long, pointed nose, demanded surgical precision. A second U-2 pilot would chase the landing aircraft in a high-speed car, providing real-time radio feedback to assist in aligning the plane with the runway. This demanding process, combined with the thin margins for error, earned the U-2 its reputation as the most difficult aircraft in the world to fly. But for all its challenges, the U-2 proved indispensable. Powered by an efficient General Electric F-118-101 engine, the aircraft could remain airborne for extended periods without needing mid-air refueling. Over the decades, it underwent upgrades that replaced outdated wiring with advanced fiber optic systems, reducing electronic interference and enabling the integration of next-generation sensors. These updates ensured the U-2 remained a cornerstone of American intelligence gathering well into the 21st century. Area 51 became more than a testing site. It became a cultural phenomenon, synonymous with mystery and intrigue. As the years passed, the rumors surrounding Area 51 grew louder and more persistent, especially as some of the secretive aircraft developed at the site began to be revealed to the public. Among the most famous of these aircraft was the SR-71 Blackbird, an engineering marvel that emerged from the Cold War's increasing tensions. In the early 1960s, the United States, anxious about potential Soviet threats, sought to create a reconnaissance plane that could fly higher and faster than anything the world had ever seen. The SR-71 Blackbird was born from this mission, developed by the legendary Skunk Works division of Lockheed Martin. Skunk Works was not just a division, it was a secretive elite team of engineers and scientists tasked with building cutting-edge technology under extreme time pressure. Led by Kelly Johnson, a brilliant and visionary aircraft designer, Skunk Works had a long track record of delivering seemingly impossible aircraft, and the U-2 spy plane was only one example of their ingenuity. Johnson and his team thrived under pressure, consistently turning out highly complex machines under tight deadlines. And their work on the SR-71 was their most ambitious challenge yet. As Johnson once said, everything had to be invented. Everything. The SR-71 was designed to be a high-speed, high-altitude reconnaissance aircraft capable of flying at over 2,000 miles per hour, an incredible speed that no other plane at the time could sustain. While other aircraft might reach such speeds in short bursts, the Blackbird had to maintain this speed for hours, which introduced an unprecedented problem: heat. As the aircraft tore through the atmosphere at these extreme speeds, the friction generated would cause the airframe to heat up to temperatures exceeding 1,000 degrees Fahrenheit, enough to melt standard materials. To solve this problem, Skunk Works turned to titanium, a metal that could withstand extreme temperatures. However, titanium posed its own set of challenges. It was a brittle material, shattering if mishandled, and required special handling and tools to prevent it from breaking. Lockheed's engineers quickly adapted, designing new tools made of titanium to handle this sensitive material, and training workers to meet these stringent requirements. Another issue was how to manage the temperature difference between the aircraft's exterior and its interior. At the aircraft's leading edges, temperatures would soar well over 1,000 degrees, while inside the cockpit, temperatures could drop to minus 60 degrees Fahrenheit. To solve this, Skunk Works' engineer, Ben Rich, recalled a simple but effective solution: black paint. Black paint, he realized, could both absorb and dissipate heat. This innovation helped cool the aircraft and earned it the iconic name Blackbird. The first flight of the original design, the A-12, took place on April 30th, 1962. The A-12 was a single-seat aircraft that set the stage for the SR-71, which featured a second seat for a reconnaissance systems officer and more fuel capacity. The SR-71 had its first flight on December 22nd, 1964, and quickly became the most advanced aircraft of its time, capable of speeds and altitudes that were previously unthinkable. Flying the SR-71 was an extreme experience, one that pushed pilots to their limits. At 85,000 feet and Mach 3, the Blackbird reached speeds and altitudes that made conventional flying seem like a distant memory. At that speed, it was almost a religious experience, recalled Air Force Colonel Jim Watkins, describing the thrilling sensation of piloting the Blackbird. Pilots had to remain focused and alert throughout their flight, dealing with high-tech systems and the immense physical and mental challenges of flying at such extreme speeds. The SR-71's speed and altitude made it virtually untouchable by enemy aircraft or surface-to-air missiles. The Blackbird could outrun any missile fired at it, and on numerous occasions, pilots would receive a warning light on their control panels when an anti-aircraft weapon was launched. By the time they checked their radar, the missile would be far behind them, unable to keep up with the Blackbird's breathtaking velocity. Throughout its service, the SR-71 set numerous records, many of which still stand to this day. It remains the world's fastest and highest-flying manned aircraft, a title it earned through a combination of revolutionary design and cutting-edge technology. Its performance was legendary. During its retirement flight from Los Angeles to Washington, D.C. in 1990, the SR-71 flew coast to coast in just 67 minutes, an achievement that highlighted its unmatched speed. The SR-71 Blackbird's legacy is not just defined by its records and technological achievements, but also by the way it captivated the public's imagination. Its sleek, black design and otherworldly capabilities made it a symbol of the Cold War's high-tech arms race and inspired countless myths and rumors about its secretive testing at Area 51. Though the aircraft was eventually retired in 1990, its place in history is secure, and it remains one of the most iconic aircraft ever built. As remarkable as the Blackbird was, its success may have been propelled by a far more enigmatic aircraft, the TR-3B Manta. The TR-3B Manta is one of the most debated mysteries in aviation. Some say it doesn't exist, while others are sure it does. Officially, the US government denies it, just as they denied the existence of other secret aircraft like the SR-71 Blackbird for years. But eyewitness reports and stories from military insiders paint a different picture. The TR-3B is said to be a black, triangular aircraft with features so advanced they sound like science fiction. Its surface is reportedly made of a special material that can absorb radar waves, change color, and make it almost invisible. Combined with its shape, which reduces radar detection, it would be nearly impossible to spot on radar or with the naked eye. Witnesses describe it as silent and capable of hovering in one place before moving with incredible speed. Its rumored engines, placed at the three corners of the triangle, are said to allow it to make sharp, high-speed turns that no known aircraft can manage. People who claim to have seen it say it can stop suddenly, accelerate instantly, and even perform perfect right-angle turns. This level of control and speed would make it untouchable by current fighter jets. What really makes the TR-3B stand out are the claims about its propulsion system. It's said to use an anti-gravity drive, a technology that would completely change the way we think about flight. This system would let it hover silently, move at extreme speeds, and travel long distances without needing traditional fuel. The origins of this technology are often linked to Operation Paperclip, a secret US program after World War II that brought over 1,500 German scientists and engineers to work on advanced projects. Some believe their research led to breakthroughs like the TR-3B. Skeptics argue that such technology would require an enormous amount of energy, far more than what current engines can provide. However, there are whispers of another breakthrough that might make this possible. Lockheed Martin, the company behind many of the US military's most advanced aircraft, holds patents for compact fusion reactors. These reactors are small enough to fit in a fighter jet, but powerful enough to produce the energy needed for something like an anti-gravity drive. Adding to the mystery is Dr. Salvatore Cesar Pais, an aerospace engineer who has filed patents for technologies that sound like they belong in a movie. These include devices that reduce an object's mass, create gravitational waves, and even modify space-time. The US Navy has reportedly invested nearly $500,000 to support his research since 2017. One of his most talked about patents is for a craft that uses an inertial mass reduction device. This concept matches the descriptions of how the TR-3B is said to work, making some wonder if his research is connected to this mysterious aircraft. Interestingly, Dr. Pais's work has strong supporters. One of them is Dr. James Sheehy, the Chief Technology Officer of the U.S. Naval Aviation Enterprise. In discussions about Pais's patents, Sheehy pointed out that other countries, like China, are also exploring similar technologies. He emphasized that the U.S. needs to lead in this area to avoid falling behind. This urgency to stay ahead could explain why the U.S. would keep such an aircraft secret if it does exist. Over the years, there have been many sightings of triangular UFOs that people believe could be the TR-3B. Witnesses often describe a silent black craft with bright lights at its corners, hovering in the sky before disappearing or speeding off. These sightings are usually dismissed by officials, but they keep fueling speculation. Some of the maneuvers described by witnesses, such as instant stops and rapid turns, are beyond what any known aircraft can do. These reports make people wonder if the TR-3B is not just real, but decades ahead of anything publicly acknowledged. Some skeptics dismiss the TR-3B as nothing more than a myth. Without hard evidence, they say it's just a story fueled by imagination and conspiracy theories. But others argue that the US military's pattern of secrecy, combined with the advanced patents and technologies being developed, suggests there might be some truth to the rumors. What makes the TR-3B story even more interesting is the idea that it might not just be an aircraft. Some believe it could represent a leap in how we understand physics and technology. If the claims about anti-gravity propulsion and other advanced systems are true, they could change not only military aviation, but also transportation and energy as we know them. Stealth became paramount in the 1980s and 1990s, a time when espionage between nations, particularly the US and the Soviet Union, reached a fever pitch. The need to operate undetected pushed military aviation to its limits, driving the creation of aircraft that could evade even the most advanced radar systems. This era saw the birth of groundbreaking designs like the F-117 Nighthawk, the B-2 Spirit, and the F-22 Raptor, machines that not only changed the face of aerial warfare, but also showcased human ingenuity at its finest. The F-117 Nighthawk was among the first to redefine what an aircraft could achieve in terms of stealth. This jet wasn't built for beauty or speed. It was crafted to be invisible. With its angular panels and unusual shape, the F-117 didn't look like anything that had come before it. Traditional aircraft designs were sleek and aerodynamic, but the Nighthawk prioritized deflecting radar waves over aesthetics. Each panel was meticulously calculated to scatter radar signals, making the aircraft nearly impossible to detect. Coated in a radar-absorbent material, the jet became a ghost in the skies. Developed by Lockheed Martin's secretive Skunk Works division, the F-117 was born out of necessity. In the late 1970s, the U.S. military needed a way to penetrate heavily defended airspace without being seen. The Defense Advanced Research Projects Agency, DARPA, spearheaded the project, holding a competition to find the best stealth design. Lockheed Martin's Have Blue Prototype 1, paving the way for the F-117. It first took flight in 1981, and by 1983, it was operational, though its existence remained a tightly guarded secret. The secrecy surrounding the Nighthawk was extreme. For years, its very existence was denied, and it wasn't until 1988 that the public got a glimpse of this mysterious aircraft. Even then, much of its capabilities remained classified. Pilots who flew the F-117 described it as challenging but rewarding, requiring a deep understanding of its unique design and behavior. Its effectiveness was proven during conflicts like the Gulf War, where it delivered precision strikes against heavily defended targets without being detected. Though retired in 2008, the Nighthawk remains a symbol of stealth and innovation. While the F-117 excelled at tactical missions, the B-2 Spirit took stealth to a strategic level. Designed to deliver both conventional and nuclear payloads, the B-2 was a game-changer in long-range bombing. Its flying wing design was chosen for its ability to reduce radar visibility, making the aircraft appear as a small blip, or nothing at all, on enemy radars. Unlike traditional bombers, the B-2 could penetrate deeply into enemy territory, hitting targets that were once considered unreachable. The development of the B-2 began in the late 1970s, with Northrop Grumman leading the effort. Its first flight took place in 1989, and the aircraft was officially unveiled shortly after. The B-2's capabilities were astounding. It could travel over 6,000 nautical miles without refueling and carried a crew of just 2 pilots, a stark contrast to the larger crews required by older bombers. Its low observability was achieved through a combination of advanced materials, coatings, and design elements that minimized its infrared, acoustic, and electromagnetic signatures. These features allowed the B-2 to operate undetected, even in areas with advanced air defense systems. The B-2's stealth was not just about evading radar. It also included measures to reduce its visibility across multiple spectrums. For example, its engines were buried deep within the aircraft to minimize heat emissions, and its surfaces were carefully designed to avoid reflecting light. These innovations made the B-2 a true marvel of engineering, capable of delivering devastating payloads with precision while remaining virtually invisible. The F-22 Raptor brought stealth into the realm of air superiority, combining it with speed, agility, and advanced technology. Unlike the F-117 and B-2, which were primarily designed to avoid detection, the F-22 was built to dominate the skies in combat. It represented a new generation of fighters, blending stealth with unparalleled performance. Development of the F-22 began in the 1980s as the Air Force sought a replacement for its aging fleet of fighters. Lockheed Martin's design was chosen after fierce competition, and the first operational F-22S were delivered in 2005. The Raptor's capabilities were unmatched. Its radar-absorbing materials and sleek design made it nearly invisible to enemy radar, while its engines allowed it to sustain supersonic speeds without afterburners, a feature known as supercruise. This combination of stealth and speed gave the F-22 an edge in both offensive and defensive operations. The Raptor also incorporated advanced avionics and sensors that allowed pilots to detect and engage threats before they could be seen. Its ability to share data with other aircraft in real time made it a force multiplier, enhancing the effectiveness of entire squadrons. During exercises, the F-22 demonstrated its dominance, achieving an incredible kill ratio of 108-0 against simulated adversaries. This performance cemented its reputation as the most advanced fighter jet of its time. These aircraft were united by a singular purpose: to slip through enemy defenses unnoticed and complete their missions with unerring precision. The TR-3B Manta, shrouded in mystery, is said to embody this mission. Stealth wasn't just about evading radar. It was about gaining a decisive tactical edge, enabling high-stakes operations with minimal risk. But unlike its better-known counterparts, the F-117 Nighthawk, B-2 Spirit, and F-22 Raptor, the TR-3B has never been officially acknowledged. Yet reports and alleged sightings have given it an almost mythical status, suggesting it might have played a pivotal role in shaping the next generation of aerial dominance. The F-117, B-2, and F-22 undeniably pushed the limits of stealth technology, but some believe their remarkable designs were not entirely independent efforts. Many theorists suggest these aircraft might have drawn inspiration or technical insights from the TR-3B. If so, the TR-3B's secrecy might stem from its role as a prototype or test bed for ideas that would later define modern stealth aviation. As such, its purpose would not merely be to exist as a singular machine, but to serve as the foundation for future advancements in aerial technology. What sets the TR-3B apart in this narrative is its alleged use of technologies that border on the fantastical. Reports claim the TR-3B operated as early as the 1990s under a classified program known as the Aurora program. This initiative, reportedly funded by billions of dollars from undisclosed budgets and coordinated by organizations like the NSA, NRO, and CIA, aimed to create aircraft that could achieve unprecedented capabilities. Central to the TR-3B's supposed design is the magnetic field disruptor, MFD, a revolutionary technology that allegedly allows the craft to defy gravity. The MFD, as described in various accounts, relies on a ring of plasma accelerated to extreme velocities within the aircraft. This plasma, created by compressing mercury under tremendous pressure and cooled to extraordinarily low temperatures, achieves a superconducting state when spun at 50,000 revolutions per minute. The resulting magnetic field is said to neutralize up to 89% of the aircraft's weight, effectively reducing the influence of gravity and enabling unparalleled maneuverability. Such technology, if real, would allow the TR-3B to perform feats that conventional aircraft could never match, including reaching speeds of Mach 9 in any direction, vertical, horizontal, or diagonal. Beyond its theoretical propulsion system, the TR-3B is rumored to incorporate other cutting-edge technologies that enhance its stealth and performance. The aircraft's structure is said to include advanced composite materials and coatings that render it virtually invisible to radar, infrared, and visual detection. These features would make the TR-3B an ideal tool for reconnaissance missions or covert operations in hostile territories. Its ability to operate undetected, combined with its extraordinary speed and maneuverability, places it in a league of its own. Despite its potential capabilities, the TR-3B remains a ghost in the world of aviation. There are no verified photographs, no declassified documents, and no public acknowledgement of its existence. Sightings and anecdotal evidence form the bulk of its legacy, with reports often originating near Groom Lake, better known as Area 51. This infamous military base has long been associated with experimental aircraft and secret projects, further fueling speculation about the TR-3B's origins. The secrecy surrounding the TR-3B has led to a wide range of interpretations about its purpose and significance. Some view it as a stepping stone in the evolution of stealth technology, a platform for testing concepts that would later appear in the B-2 Spirit or F-22 Raptor. Others speculate that the TR-3B represents a leap beyond conventional aeronautical engineering, incorporating principles and technologies that seem almost alien in nature. The latter interpretation has even led to theories that the TR-3B might be reverse engineered from extraterrestrial craft, an idea popularized by UFO enthusiasts but dismissed by mainstream science. If the TR-3B indeed exists, it would represent the pinnacle of the X-plane tradition, a series of experimental aircraft designed to test new technologies and push the boundaries of aviation. The lineage of X-planes includes historic milestones like the Bell X-1, which broke the sound barrier, and the SR-71 Blackbird, which set records for speed and altitude. These aircraft were not built for mass production, but to explore the limits of what was possible, paving the way for operational designs like the F-117 and B-2. The TR-3B, however, might surpass even these legendary planes in its significance. While the F-117 demonstrated the feasibility of radar-evading stealth, and the B-2 introduced long-range, low-observable, strategic bombing, the TR-3B is rumored to embody a paradigm shift. Its reported capabilities suggest a level of technological sophistication that could redefine aerial warfare and surveillance. By neutralizing gravity's influence, it could operate in ways that are unimaginable for traditional aircraft, reaching speeds and altitudes that would make it nearly untouchable. As with any secret project, the lack of concrete evidence fuels both intrigue and skepticism. The TR-3B's existence has never been confirmed by any official source, and much of the information about it comes from unverified accounts and speculative reports. Yet the consistency of these accounts, combined with the known history of experimental aircraft development, keeps the legend alive. Perhaps the most compelling aspect of the TR-3B is its potential role in shaping the future of aviation. If even a fraction of the rumored technologies are real, they would represent breakthroughs with applications far beyond military use. The principles behind the MFD, for example, could revolutionize transportation, energy, and even space exploration. By reducing the effects of gravity, such technology could make high-speed, long-distance travel more accessible and efficient, opening up possibilities that are currently confined to the realm of science fiction. For now, the TR-3B exists as a shadowy figure in the history of aviation, a whispered legend among enthusiasts and experts alike. Whether it's a real aircraft, a conceptual prototype, or merely a myth, its story captures the essence of human curiosity and the desire to reach beyond the ordinary. Perhaps one day the truth will emerge, shedding light on this mysterious craft and the role it played in shaping the skies above. Until then, the TR-3B remains a captivating mystery, a symbol of the unending quest to push the limits of possibility. But what if the TR-3B isn't just a relic of experimental aviation, but a glimpse into the future of humanity's conquest of the skies, and perhaps even the stars? Thank you for watching another episode on our channel. While you are still here, click the video on your screen to see more mind-blowing videos like this one.